Hi, welcome back. Today we're going to be taking a look at how to convert our controller code into the basis of our Hovercraft code. The Hovercraft code is going to be much more complicated. It's going to take the raw data from the controller and then process it in all the ways we've learned and output motor speeds to all three motors. Before we get to that though, I'll show you today how to set up the program, set up the Hovercraft code so that it takes the data, it receives the data from the transceiver and then unpacks the data and gets it ready for processing. The processing half is going to be kind of up to you. Okay, this should be fun. First thing you want to do is open up your controller code. The Hovercraft code is going to have the same basis because it's still using that radio transceiver. So first thing you want to do is we're going to make a new version of this. So find the name of your file in your sketchbook, and over here next to the triangle, click on it and then say duplicate sketch. And it's going to make one and open it that's called copy up here. So we're going to click up here, erase all of this, and call this Hovercraft code. And I'm going to call mine video version so that I know which one it is. You don't need to call yours that. All right. Give it a second to update all of that. It'll flash and we're ready to rock and roll. Now, in this Hovercraft one, we're going to actually be sending motor commands. To do that, we need the servo library. So up here where it says include, I'm just going to copy and paste this one. Or maybe I'm not. That was weird. And then I'm going to change this one to pointy bracket, capital S for servo, and then .h, and then close pointy bracket. Let me make sure I did that just right. Yep, awesome, capital servo, yep. Okay. So now we've included the library for the servo motors and the SPI and the NRF light libraries. All of this we need to keep. The only thing we need to do is we need to change the radio IDs. So because now we're talking about the Hovercraft, it's going to consider its little radio transceiver as the primary and the one in the controller as the destination radio. So if you had these labeled 0 and 1, just switch them 1 and 0. So they just need to be backwards to what they were before. And then everything else we need to keep because we need to make sure the channel stays the same or they can't communicate if they're on different channels. Down here for line 15, we don't need the pop pin anymore because we're not reading potentiometers. So I'm going to go ahead and delete the pop pin. I'm going to leave the pop value because what we're going to do is take the data packet array that we got from the controller and we're going to unpack it, break those three things apart into three values. One of them will go in the pop val, the other goes in the X val, and the other goes in the Y val. But I don't need the pin numbers, so I'm going to go ahead and delete all of the pins out of there. All right, and then the data packet. This is on the controller side. We're going to call it received data. So let's go ahead and change our array, and let's change the name of it to received data. So when we receive the data, it's not going to have the name data packet attached to it. It's just going to be the raw three data numbers. So we'll create this new array called received data, and that will give the transceiver somewhere to put that data when it shows up. All right, and I'm going to leave the 512, 512, and 0. And we have to remember this is, let me put a little thing here. This is the X value, Y value, and pot value. So they're in this order. That's important to know that because we're going to need to unpack them. And we need to unpack the first one into X val, the second one into Y val, the third into pot val. All right, that's good. That's set up and ready to go. Struct we need, leave that in there. It creates that potential for having a packet. Radio objects and radio data objects we need, leave those alone. Keep the serial begin so we can check on stuff, as always. And the if statement we want to lead in here. And notice that the new radio ID will be the other one now. It'll be the one for the Hovercraft. And down here we have radio ID. That needs to stay as well. Nothing changes in the serial void setup. You will, oh, one last thing. Up here before setup, don't forget, in order to use a servo library, you have to name your 3 motors using the servo command. If you're not quite sure how to do that, look back on previous working pieces of code and find those chunks of code and bring them over. And then inside void setup, you'll have to do attach commands to tell the Arduino what pin numbers all of them are attached to, which means you'll probably need some variables as well for that. So just a heads up, those things will have to happen. All right, let's skip down now. We need everything in void setup to stay there. Void loop, we're going to go ahead and get rid of this. This is for reading the analog pin of the joystick. That happened at the controller. We don't need that. We don't need the Y or the pop val either, so I'm going to delete all that. This is for packaging the data up into one thing. We don't need to do that. It's already been done. And this is for sending the data. We don't need any of that. So really, we just need an empty void loop at this point. All right. Next thing we need to do is actually add in we need to add in the commands for reading the data. So how we're going to do that is with an if statement. So we're going to say if open curly brace. So there's a command in the NRF flight library that is underscore radio dot has data, and the D for data is capitalized. So this is and then open and close parentheses. So radio dot has data. This is a function that when it runs, it asks the little transceiver, so it asks that little device that's on the thing, is there data, have you already received data from somewhere else? If the answer is true, this goes to true and 1, and the if statement runs. If it doesn't have any data in it, it runs as false, and it will skip the if statement. So to put something in the if statement, we need an open curly brace here. So we don't use a semicolon, we open with a curly brace, hit enter, and notice Arduino's added automatically a closed curly brace. So if the radio has data, if this is true, it has data, it will do whatever is inside the if. If it is false, it doesn't have data, it will skip the if statement. Okay, so inside here we need another command from the library. It's underscore radio again dot, and this time read data. Open parentheses. Inside here, this command will read the data and then store it in whatever is inside here. And we're going to use an ampersand, just like we did before on the send data side. And we're going to put received data in here. In fact, I'm going to come up here and find my, there it is, find my variable up here, and I'm going to put it down here. Just to make sure I don't mistype it. And then I'm going to hit a semicolon there to end that line. So here's how this works. It comes here and it says if radio has data, it checks the radio to see if there's data waiting. If the answer is yes or true, it's going to say, okay, read that data and store it in the array called received data. All right. So at this point, we should have data stored in from the controller. We should have updating data being stored in received data. Now we need to just break it down real quick. So we're going to take the received data packet and break out those pieces of data from it. The way we do that is we go x value, so whatever value you want to start with, is equal to, and remember we said the x value was this first element, and confusingly enough we start numbering 0, so this is element 0. So we say, hey, take the received data, again I'm going to copy and paste so I don't make mistakes. Element 0, and I'll put a semicolon at the end to end the command. And what this does, it tells Arduino, hey, go find the number that's stored in received data element 0, the first position, store it in the variable called x value. So take this number, put it in here. So let's put a comment in here and say this is gets the number in the first position of received data array and stores it in X value. All right, I'm going to close this down here. I'm going to make this a little shorter. I'm going to get rid of some extra words in here. In the first position of received data, and stores it in X value. I want to be able to read it on one screen. Okay. So we just need to do that now 3 times. One for X, one for Y, one for pod. So Control C, V, V, and V. I'm going to change this X value to Y, this one to 1, and this is going to be the second position, and it's going to be Y value. This one changes to pot. This changes to 2, the third position. This changes to third. And this changes to pot. Awesome. So now what we've done is we've seen if the radio has data. If it did, it was great. Grab that data, put it in the received data array, then break out each piece of that array and store it in its appropriate value. Now to see if this is working, let's go ahead and print, serial print some values here. So underneath here, I'm actually going to put them underneath each one. Whoops. Open up a little bit of space between each one. I'm going to do a serial dot print, and then here X space, whoops, quotation marks, X space equals space, semicolon, copy and paste that, and then without the parentheses I'm going to type in X value. And I'm going to put those 2 lines of code after each of these. I just change them around a little bit. Space, space, and then this is the Y and Y. Space, space. I'm just call this one P, just save some space, and this one has to be pot. Awesome. So it's going to receive it, put it in the X value, and then display that on the serial print. This last serial print down here, I want it to kick to a new row, so it just has those 3 datas across. So I'm going to put L in on the last one here. And now I'm going to test this to make sure this is working. So now I need to fire up 2 computers, one with the controller code working and one with the receiver code working. So now as I change the joystick over here on the controller, it should be updating the screen on my Hovercraft code for all those values changing from the received data. If that worked, awesome, you're ready to build the rest of the program. If that didn't work, it's okay, you're in problem solving mode. It's part of the fun and joy of robotics. Best of luck to you.